Okay, I think we can make a start. Good morning, afternoon, or evening to everyone. My name is Alan Stephen, and I'd like to welcome you to the October edition of the webinar series organised on behalf of the RSC's Process Chemistry and Technology Group. Before we get started, we have a few housekeeping items. Please stay on mute. Please place any questions for the speaker in the chat, and we'll get to them at the end of the presentation. The webinar is being recorded, and we'll distribute a recording of it afterwards to all the registrants. Finally, I've placed a link in the chat to our annual event, which you might be interested in attending if you're in the UK. It'll be in Leeds on the 21st of November and is on digital chemistry, and there will be a workshop the day before on design of experiments. With that, I'll move on to introducing our speaker, Devin Baier. Devin performed graduate studies in education and taught in high schools and colleges for a number of years before moving into technical business development with Polar Clean, who are a part of Premium Plant Services. In his role there, he educates around niche cleaning solutions with an emphasis on dry ice cleaning technology, which he's going to tell us about today. So with that, I'll hand the floor over to you, Devin.
Great. Thanks, Alan, very much for that. Appreciate the opportunity. Hopefully that you find time valuable and that I can, meetings stink as it is. So hopefully I bring value today over anything else. So with this, I am, as I had mentioned to Alan earlier when we were talking a minute ago, I'm going to move quickly because there's a lot of content that I was asked to cover during this. With that, just kind of give you an overview here. One, I want to address why I was brought in and what I'm addressing. I know sometimes when a company is talking to you about different methodologies, it'd be nice to know who the heck they are and what do they know, where's their credibility in that. So I want to introduce our company a little bit just for that purpose, and then talk about dry ice blasting or cryogenic cleaning, CO2 cleaning, different names for it, what the projects look like, how that project design comes together, and then address customized project design in general for different industries, go through several examples, and then do some discussion at the end. So that's the ultimate goal of what we're doing today. But we're going to jump right into it to be good on time here. So why I was here, the primary purpose that was explained to me is to bring in some alternatives to cleaning with solvents in the pharmaceutical industries, also in others that, include different verticals, and we work in many, but bring in an alternative to cleaning with solvents in the pharmaceutical industry, talk about process development with picking a methodology for cleaning equipment or facilities in those realms, and then do questions about the related content afterwards. With solvent cleaning, we work a lot in many industries, pharmaceutical being a very common one for us. Cleaning by hand with solvents is very common in the industry. Sometimes it is absolutely the best fit, and there are moments when that can't be denied, but sometimes there are better options, and that's how we've worked so extensively in that market to do different ways of cleaning different scopes. And we all know that it may be the best solution, cleaning with a solvent, but we also know the problems that are there, and you in the industry know this better than anybody. There's environmental concerns, sometimes safety, time constraints of doing things by hand, contamination risks with product, and other things too. So that's why sometimes looking to an alternative can be a positive thing. There are many, right? But a big one that we use commonly is dry ice blasting. And sometimes dry ice blasting can be used solo as a replacement of cleaning a certain way, or it can be used in a combination clean scenario to where sometimes it is good to still use solvent on certain components of the machinery or to help loosen up the adherent that's on there, and then utilize dry ice cleaning as well. So it's not a one or the other. It's not this is always better than that, but just here to present an option to you to consider as you do preventative maintenance and things with your shutdowns in your facilities. And then talking about cleaning process development, that was another big piece of it, and we're going to get to that later. But the development of coming up with a cleaning plan for preventative maintenance during a shutdown, depending on your course frequency of those. But going through a little bit about discussing how we as an industrial servicing company come up with that to kind of maybe seed some ideas on development of a cleaning plan. Talking about validating and testing and verification that the process that you've selected is working and what adjustments that you might need to make moving forward. So kind of the whole picture there a little bit. And I know that your group is very used to this type of process, but I was asked to bring it up again as something else to keep everybody fresh and looking at a new idea here. Quickly, I don't want to spend long on this because this is not the interesting part to you, but I'm with Polar Clean Dry Ice Blasting. We're a division of a larger company in the United States called Premium Plant Services. We have multiple locations all over the country, and we work all 50 states. We have done some international work as well, but we are an industrial cleaning service company, and we focus on blasting of many different types. And so that kind of paints who we're working for. At any given time, usually we have about 90 trained blasting technicians that are dispersed throughout the country, working in different environments. So we've got a lot of experience in different industries, refining and petrochemical. We do a lot of work in that sector as well. Marathon Oil, Chevron, Phillips 66, some of the big oil tycoon companies. We do a lot of work for them. Power generation, especially where you're at in the UK, you're very familiar with Siemens, or at least some of you are, Siemens and GE. We do a lot of rotary equipment cleaning and cleaning of turbines, compressors, generators for them. In manufacturing, this is where we kind of group in things like pharmaceutical, food and beverage, general manufacturing, other industrial manufacturing. So we're in there cleaning machinery, the facility itself, food processing or pharmaceutical processing equipment, and many different things. So manufacturing is a very big category, and then restoration facilities too. We're cleaning historic buildings. We do general renovation. Purpose of my rant here is to just let you know that we have a wide range of experience with many different industries and settings. And so me coming at here with an alternative to a particular cleaning solution is really just coming from years and years of experience of doing it in different markets, different ways. So we've seen a lot of different opportunities for different methodologies per se. The blasting type that we're going to hit today is dry ice blasting. And I'll go through and explain the basics of what it is, but it is cleaning with carbon dioxide is what it is. And that is one of our biggest bread and butter blasting types that we utilize a whole lot across many industries because it is non-abrasive. There's no water, there's no chemical introduction, and it's a very food safe, food grade way of cleaning without introducing excess materials in the blasting process. We also perform these others too. So we have that side-by-side comparison with experience of them. Abrasive blasting or sandblasting, using all types of media from walnut shells to baking soda to crushed glass, aluminum oxide, any type of media you can imagine, we blast with it depending if the application's right. Used when you need abrasion of a surface. Sponge blasting is an alternative to abrasive that's less dusty, but is still abrasive. And it's just using little pieces of sponge with abrasive embedded in it. We blast with that a lot in the food industry and pharmaceutical industry or historical restoration, because in scenarios where you need cleaning done that takes abrasion, but you can't have the dust of traditional sandblasting, we utilize sponge. And then we also do hydroblasting and vac services too, for instances where water is acceptable and you can use a large volume of water to do cleaning. So we've got all these industries we work in with all these methodologies. And one of our favorites, especially for the industry and verticals that many of you work in, is the dry ice blasting. This chart here you can look at later and focus on more and scoping it out, but it's just talking the differences between them. Focus on the dry ice blasting here. You know, it's really where you're in an environment that you need to clean something aggressively that it can't be done by hand well, or you want to try to find an alternative to a solvent, but you cannot introduce water, you cannot introduce media that's a contamination risk, and you don't want to be damaging the equipment with abrasion. Dry ice blasting is the ticket, and that's really the focus of a lot of what we're talking about today. This here is another comparison here, just talking cost and, you know, dust and things like that. Again, the focus here is it's not the most inexpensive trade in the world, but you know, it takes a lot of these factors like dust and contamination risk and abrasion to equipment out of the equation and gives an opportunity to clean either facilities or equipment itself. Okay, so to discuss this sum, what is it? And I'm not sure at the familiarity of everybody in the room on where you're at with it. So I'm going to start at the basic and move through. Again, questions will be there as you have them. We can talk about them at the end. On a basic level, imagine pressure washing or sandblasting where you've got a technician with a nozzle propelling something at a surface, but we're using dry ice is what we're using to clean. So you've got, you know, an air compressor machine, air lines in, blast lines out, you know, a gun or a nozzle, and we're shooting out dry ice at a surface to clean it. That's at a very high level exactly what's going on there. I don't know, Alan, I'm going to try this video. Don't know how it's going to go through this, but I'm going to play it, and hopefully there can be some value in this. If not, we'll skip over it.
We now return to deep freeze on Modern Marvels. It's tough enough to clean the dirtiest grime, yet gentle enough to restore irreplaceable artifacts. Blasted onto any surface, it disappears on contact. And at minus 109 degrees Fahrenheit, it's extremely cold. The magic ingredient that's making it all happen? Frozen carbon dioxide, better known as dry ice.
We put it into a system that's sort of similar to a sandblasting unit, and we propel the dry ice from rates of 600 feet per second to about 1,000 feet per second. And as it strikes a solid item, it sublimates directly into a gas. There is no evaporation process. It's directly solid to gas. Demonstrated like this. Small quantity of dry ice at a high velocity into a solid item, and it just goes into a gas.
The frigid temperature of the dry ice blasting against the grime causes it to shrink and lose adhesion from its subsurface. As that happens, the dry ice explodes into vapor, expanding 800 times its original volume.
So there's a mass of the dry ice striking the surface, the extreme cold, and this explosion that is helping to remove the contaminants.
The process has been used to renovate nearly 100-year-old roof tiles at the Philadelphia Museum of Art. Dry ice blast cleaning removed the built-up tar without scratching the irreplaceable tiles, each worth an estimated $10,000. It's even used to strip crystal buildup in wine barrels and to restore smoke-damaged buildings. Don't want to get your antique book wet while cleaning it? No problem.
Less just dusting the surface of the book. Doesn't damage any surfaces that are harder than dry ice. Dry ice on a scale of 1 to 10 is about a 2, with diamond being a 10.
Of course, when people think of dry ice, they don't.
So that's good enough for that one there. And really what's good about it is to show exactly what it's doing visually, but also introduce the fact that it can be very gentle, because when anybody hears blasting with their equipment, there's immediate pause, right? And it's this entire trade was designed to be able to effectively clean surfaces without damaging the substrate underneath. Okay. So this video here, I want to show a minute of it if it will let me. It may not. It looks like it's not going to want to do this. Hold on, let me try this. Okay, that video continues on where they give a little bit more of a pitch for their equipment, but not the focus of what we're up to today here. But again, more visual there on what's happening and how it's actually operating. So moving on here, big things with this process, and basically the way dry ice cleaning or blasting happens in three pieces is that there's a kinetic energy transfer, right, from the dry ice pellet itself hitting the surface. There's a thermal shock because of the temperature differential there. You know, of course, being an American, my brain runs in Fahrenheit, but it's 109 below zero. So extremely cold. And what that does is that cold temperature causes adhesion breakage from the substrate and the adherent. And then when dry ice sublimates, because it goes straight from a solid state to a gas, it expands at 800% very quickly. And so what happens is you've hit the material, you've thermally shocked it to where it disassociates with the substrate, and then that gas expands quickly and pops things off the surface. And that's how it goes about doing its cleaning process. And as they were talking about the hardness of the dry ice itself, it's a 2 on the hardness scale. So it's not going to damage anything that's harder than that. This is a way that easy to remember it. Ice. We're talking about dry ice. It's ice. It's impact, cold, expansion of gas. You know, thinking about how it truly goes through and works in the process. And then another visual. Impact, cold, expansion to be able to remove adherence. Talking about what it can do. It is very good at cleaning surfaces, right? That is truly what it was designed to do. And it's cleaning a surface without the introduction of water into the process, which I know in pharma and in food and beverage for our clients that we work with them, you know, water introduction is almost as bad as another contaminant, right? Especially in the food industry, because you don't want unnecessary growth with extra moisture. So there's no chemicals, there's no water, and there's no other media that's introduced. So again, why this particular methodology has been popular in those industries and is growing rapidly. It can be fine-tuned. So one of the sayings that our founder said many years ago, and it always stuck with me, is that we can clean the M off of an M&M chocolate, or we can remove welding slag. And it's all in this range and how we tune the machine on what we're cleaning. So that opens us up to have a very diverse bag of options when we're cleaning a piece of equipment or a facility or however. So it can be very tuned, and to, you know, show that in the steel industry, we clean a lot of electronic panels for them because they get fine metallic dust on these electrical panels. And especially in things like switch gears or control cabinets, it can cause arcing and a problem like that. So they've got to be able to clean it, but they can't just wash it. And sometimes blowing it out with air isn't enough. So it is tunable low enough and gentle enough to where we can clean something like this. And this is really just to highlight the fact that it can be aggressive, but it also can preserve your equipment 100% if we can blast electrical panels with it. What it doesn't do, that's as important as what it does do. It does not profile the surface. It is not abrasive. Most of the time, that is the goal. We don't want abrasion. But if you have a scenario where, let's say you're completely taking a piece of equipment offline and you're planning to repaint it, and if your coating calls for a profile, a surface profile, ice cannot do that. There has to be some more abrasion there. So it cannot profile it. Could be an advantage when you're trying to avoid that entirely anyways. We can't make the adherence disappear, right? So whatever we get off of the surface has to go somewhere, and that's part of the project design that we'll talk about too. You know, when you're cleaning equipment in your facility that is kept really tight with your cleanliness standards, when you design your project, you have to be thinking about where are these adherents going to go, because they're going to get displaced. So containment is an important piece of that thinking. How do we make sure that as we're cleaning this, things stay here and we can do proper cleaning of it afterwards and not contaminating other areas? And it's not good at removing staining. Say you're working on a piece of equipment that's been either discolored because of temperature, or say it's a painted surface and there is a material that has stained the coating, we can't, and we're not removing the coating because it's not abrasive, so staining will remain, but the surface will be clean. So just things to be thinking about there on what it can't do. And this is important too. I know I'm sitting here across the screen from you touting about how great dry ice blasting is, and truly love the trade, but it's only should be used when it's the right fit. And I say that because if there's a better way, then it might not be the right solution, but it's a solid alternative in certain moments that you may have. If you absolutely need to avoid water, if you can't do profiling, you can't abrade the surface, you can't have contamination from an abrasive or chemicals, or you don't have the manpower to do it by hand. When you've got most of those scenarios bundled in one, that's when looking to dry ice blasting is a good alternative. If you sit in a scenario where you're talking about a piece of equipment that is not water sensitive, you've got all the manpower in the world on your PM. If you can pressure wash a piece of equipment, it doesn't make sense to bring in dry ice blasting as an alternative to it if you've already got a methodology that works and it's not a risk to your environment or your equipment. But if you've got this combination of factors, that's when really considering this trade might be a good thing to do. All these industries, pharma, food and beverage, very common in those, petrochemical, manufacturing of all sorts of different types, power generation, restoration, a lot of government work we do with dry ice blasting. It's very, very common trade and really gaining traction, especially here in the US. And I know it is over in Europe as well. We traveled overseas 2 years ago, just as there was demand for dry ice blasting, and we were the company that they called over to do it. So it's gaining a lot of popularity all over the globe. Things it can remove, and this is important: dirt and grime. It could be production debris, and that's a very wide term, but it really depends on what you guys have going on as far as your individual production process. Are there adhesives? Are they powders from your process? Are there liquids? Are there left behinds just from a leaky gasket or something that's accumulating in a spot? Grease and oils from moving parts, mold, right? Soot, carbon, rust and corrosion, minerals, flaky paint. If combustible dust, I know, is a thing, especially in the food industry. Fire retardant insulation, lots of things that can be used or cleaned with dry ice blasting. Biggest one, I guess the more umbrella thing that's going to be most common is going to be the production debris, probably in what we're talking about today. Where does the dry ice come from? I caught a question out of the corner of my eye about the grade of dry ice, and we'll address that here too. The source of it. It's a very green process. I know that's a big movement here, but what's happening is we're capturing carbon dioxide from different industrial processes. So fermentation is a big one. In the United States, we produce a lot of ethanol, and we capture the CO2 from ethanol to produce dry ice with it. Beer. Right? Beer puts off a lot of CO2. Distillation and liquors, a lot of the distilleries we work for, they capture their CO2. So it's coming, what would be a waste product is captured and collected because of environmental standards, right? But then they capitalize on that by capturing that CO2. Oil and gas refining, ammonia and hydrogen production. You think, well, why would we be making ammonia? Fertilizer production is a big one here. A lot of fertilizer companies produce a lot of ammonia for that, and hydrogen for that matter, and they produce a lot of CO2 in that process. It's captured. Biogas, landfills put off a lot of CO2 that many landfills now are capturing. So what would have been a byproduct out into the atmosphere, they're now capturing. And what they're doing here is they purify it. So the question I caught out of the corner of my eye about the grade of dry ice, they capture the CO2, then they purify it to achieve food grade status, because the largest consumers of dry ice need food grade status, and that would be food and beverage and pharmaceutical. So yes, absolutely, all dry ice. I can't say all. I've ran into a couple companies that do produce it that's not food grade, but I would say 99% of every company, when they produce dry ice, it's going to be food grade because of that purification to get to that point with the CO2. And they pressurize that CO2 and cool it, and it condenses into a liquid, and that's how they store it in tanks and transport it as liquid CO2. Then to turn it into the dry ice that's usable, that solidification process, what happens is when it's pressurized and it's cooled in liquid form, when they release that liquid CO2 into normal atmospheric pressure, but they do it very quickly, it expands so quickly, and it's a process that causes a real rapid temperature drop and creates this snow-like consistency. It really is just like snow. It's very fine, powdery, dry ice is what is produced from that reaction of the rapid expansion. Then they take that snow in machinery and they compress it hydraulically, either with corkscrew presses and things through different molds or into blocks. And that's how they actually produce the dry ice itself. So it's taking that CO2, capturing it, purifying it, liquefying it, letting it expand, and then compressing that snow into usable dry ice. And that's the source of the ice for that. The largest consumers being food and beverage to keep things cool, pharmaceutical and healthcare. Healthcare, of course, big as you know, is keeping things cool and transport and storage. And then third in line is industrial cleaning. So you think about how much dry ice is used for food and beverage and pharmaceutical and healthcare. Next in line is industrial cleaning. Companies like us that are traveling around the country cleaning with dry ice blasting. So it is a very popular trade and gaining a lot of traction. The futures here, just a quick note, because there are several CO2 processes that are actually decreasing or suppressing. So we're producing, like in the States, we're producing less ethanol, which means there's less of that CO2 output. Beer is actually on a decline stateside. So, that brewing process is declining. So the sources of dry ice are going down, but the demand for dry ice is going up. So there's definitely a change in cost of dry ice over time. But right now they're working on sourcing some things out. The government, the American government, is at least providing some paybacks to companies that instead of selling their CO2 to companies that would produce dry ice, the new thought is that if they pump it into the ground, that's the more environmentally friendly way of handling that scenario. Won't go into a political discussion about that whatsoever, but sources of CO2 are varying right now, but popularity and what dry ice is and what we need it for across industries is still there and gaining traction. So they're starting to get creative on how to source it. Okay. A dry ice blasting footprint, to perform a project like this, you need a lot of air pressure. You can clean with what we call shop air if you have air in your facility, but the pressures and the air volume that are normally present in most manufacturing facilities of any kind are not enough to do really heavy grade blasting with dry ice. So usually there's a diesel or a large electric air compressor involved to power the air. You've got large air lines, the blasting machinery itself that ice gets put into. The dry ice is stored in these totes. They're about, I'll do some rapid conversions in my head. They're about a meter and a half long, a meter tall, and a meter wide, and they hold, 250 kilograms of dry ice in them, and they wheel them around. And that's what stores the pellets that get shoveled or scooped into the machinery. that forced by air coming out a hose with a blasting applicator and nozzles of various types, depending on what you're cleaning, onto the equipment surface. So when you're thinking about something like this, what kind of impact is this going to have on my facility, when we're in a down and we're doing some preventative maintenance? Big picture is you've got an air source outside, just some hoses that run in, a small machine, and totes to store ice. And that's the big as the footprint becomes when you're utilizing this type of cleaning at your facilities. Some questions that come up frequently that I want to make sure that I addressed. Containment. What do you do for containment with a dry ice cleaning project? It seems like I'm dodging a solid answer here. It really does depend. Is the material hazardous? How dusty is the material? What's around it? If we've just got to be thinking about displacement. If I'm cleaning something that is non-hazardous and it's not dusty, there's not a lot of containment that's needed at that point. But if I'm cleaning a hazardous material that's very dusty, now we've got to do custom containment plan where we've got to enclose the area and do negative air draw and do HEPA filtration to make sure that the dust that's being disturbed here doesn't end up out here in the facility and contaminating things. So it truly depends on the exact or specific scope of what's going on. But the ultimate goal is that there is no sense in using a cleaning method that creates more cleaning somewhere else. So always have to have the thought of containment when embarking on a dry ice blasting project. Air quality. Okay. This depends too. It is carbon dioxide, right? So it is changing the composition of surrounding air. And if it's in a wide open space, large production floor that's on ground level, there's no concerns really at all whatsoever, because remember, we're using an air compressor to propel the dry ice. So we're pumping in large volumes of HEPA filtered fresh air in with the dry ice. I did some conversions here, a little over 11 cubic meters per minute of fresh air versus the less than 1 cubic meter per minute of CO2. So that combination there's a lot of fresh air getting introduced to the process. Where it has to be considered is if it's subgrade or in a confined space. So if you're wanting cleaning done inside of a tank per se, a storage tank for some of your materials or something like that, or you're working in a basement level at your facility, that's when considerations really need to be taken, because carbon dioxide sinks and settles. So in those confined spaces, even though we're introducing in a lot of fresh air in the actual blasting process itself, the CO2 will sink. And so if you're subgrade in a basement or if you're in a tank, you have to be thinking all that CO2 settling at the bottom and becomes an immediate risk to life and health for a technician blasting in that environment. So then you have to make adjustments in the process. So for us, we always monitor. We wear monitors on our belts that are air quality. And then we also, we call it a sniffer, a room sniffer, but it's an external air monitor that's also taking readings. And if we're in a confined space, we always use supplied air, like an SCBA system that's pumped in fresh air elsewhere. So if you're in those confined spaces or subgrade, something to consider. If you're out in your normal production floor and it's wide open spaces with air moving, it's not a concern whatsoever. What can you reach? That one's commonly asked. Imagine pressure washing something, and if you can reach it with that, you can reach it with a dry ice blaster, and that's really the easiest way to express that there. If we've got, like, this is one of our technicians, Brandon, here cleaning a vessel, and you can see, he's standing toe to toe with this equipment, cleaning it. There are times where maybe we're cleaning internal diameters of piping. We do have lancing equipment, that we can send a lance down an internal diameter of a pipe and clean with dry ice. And we do have a robot that can go into duct work and actually goes up into the exhaust ductwork of facilities, and dry ice blast the idea of the ductwork in those facilities. Those are things where we can be more hands off. But if we're cleaning equipment or walls, ceilings, anything like that with dry ice, imagine that you're standing toe to toe with a pressure washer. That's how close we have to be. So that creates the next question: access, right? We have to have access to it. If we're working on a large piece of equipment for safety, we might have to have scaffolding built around it or use aerial lifts. Or if we're down in a tank, we might actually do trapeze suspension, down into a tank to work in there. But you cannot, and something to think about for yourselves in the future, you cannot dry ice blast from a ladder. It is not a safe process. I've seen companies do it and people get hurt because you have to imagine you're hanging on to a lot of pressure on a ladder. So as far as safety risks, for us as a company, it's an absolute no. You have to have a solid platform where you have fall protection if you're in an elevated space. And then, if it's access into a confined space, you have to follow your safety procedures there too. With us, of course, it includes hole watch and bottle watch and all sorts of other personnel there to help with confined spaces. But we have to get close enough to work on the material. Waste. This is another one. Okay. Depending on what you're doing, if you're talking about pharmaceutical waste, it really depends on what, I'm not sure if you use the same terminology like an SDS sheet, the risks associated with that particular component. You have to make sure that it's properly disposed of, right? So you're not going to create any new waste with dry ice blasting. The only waste that's going to be present is what was already there, and you just displace it from whatever surface you're cleaning. So that's the good news about it, is you're not making more of a problem, but now you've displaced this material, and you have to keep it contained, collect it in the proper way, and then dispose of it properly as well. Now with that, in your facilities, pharmaceutical facilities that we work with, I know that they already have waste companies that they work with that get rid of, product that is not usable, et cetera, or just from generalized cleaning around the facility. You likely already have a vendor for that you use for that same material. Since we're not making any new different material, when you clean with dry ice, contain, collect, you can dispose of in the same fashion that you do that same material otherwise in the facility. Okay. And usually if you have an external company come in to help you with this process, they're going to lean on you to do that too, because for an industrial cleaning company to go through and find vendors for the disposal and go through that whole rigmarole to get it done, it is way easier since you've already got somebody in place for that same material that you're already producing at the facility. So biggest thing is keep what's already there contained and then properly dispose of the way you normally do. Combination cleans. Yes, absolutely. This happens. It's it can be done many different ways. There are scenarios where we get, we'll end up getting a scenario where there's an adherent that the only way that it can be removed from the surface or softened enough to actually go through the cleaning bit is that it has to use a solvent. Dry ice can clean some pretty hard things, so that's very, very seldomly the case. But there might be scenarios where you have to use a solvent in an area on, say, a production surface or something like that, and then blast it with dry ice. Or after we blast, if it's food production, or same with pharmaceutical, is that you guys have sanitation procedures that you do on the regular. So after a dry ice blast, even though it is food grade and it is going to clean to a very clean level to where you could do a test like you had already sanitized and it's going to pass most likely, you still have to go through your normal sanitation afterwards. Or other scenarios where You might blast with abrasion, but then dry ice blast afterwards and use some kind of sanitation process after that. So there are a lot of possibilities here for using blasting with combinations of other methodologies. There's no just one way to do it all the time. It's really about finding the best way to tackle that, moving forward. Okay. This here, I know I'm moving quickly, and forgive me here for that project design. I want to hit it kind of quickly and lightly here, and I'm going to go over it quickly. I saw another question pop in, and I know we'll address it later too. So I did catch. So with this, coming at it from an industrial cleaning company that's in all these industries, right? So that's why I painted that picture at the front. We see everything in all different types. When you have a cleaning project that you need to tackle at your facility, this is how we think about this design when we work with different clients in different industries, just to kind of share that too. You always want to start with the end goal in mind, identify what limiting factors you're going to have for that particular project, and then reverse engineer it with how. Okay. We run into a lot of companies all across the country that their reason for cleaning something a certain way is, well, we've always done it that way. Okay. I mean, that's fine. That's a valid answer, but that's as far as coming up with the most effective way to do it. We all know that some external thought and processing might be helpful with this. Starting with the end in mind, right? What is your ultimate goal? And we'll get this commonly. Well, we need to clean this piece of equipment. Okay, we need to refine that a little more. Well, this, and this area on the equipment needs cleaned. We need to be very specific. The more specific you can be at the start of your venture with this equipment, the better, because everybody's going to be more clear on what needs to be accomplished and at what validation level we need to have. Okay, the machine, this extruder needs these two lines A and C cleaned because there's bicarbonate caking on there, and we need to get that off and do a test to make sure there's none present, so we can do a product switch over in December and it's not a contamination risk. That is a good end goal that you can derive after doing some of that processing in your head. The validation piece of this is big because in the chemical, pharmaceutical, food industry, validation comes with, we need to get it to this cleanliness standard, and we're going to run these tests on it to verify that it is at that cleanliness level. So even when you're identifying your end goal, you have to make sure that that's a piece of it that you identify out loud and that all parties involved know this. In other industries, it's more of a visual clean. There might not be testing. When we're working in gas and oil, make it look good. Make it look good. If it's, most general manufacturing, get this adhesive off of there, make it look good. And that's fine. And that can be done that way. But in your world, that validating is more important, right? Thinking about the factors with a project where you might utilize a different methodology. What can limit this project? What are going to be the pitfalls? Is it damage to equipment? Is it containment of the material? Is it safety concerns? Is it hazardous materials, the environmental constraints? This might be something that you guys run into. We know that it's a big push here stateside with elimination of many chemical components for cleaning. So you have to find other methodologies that are more environmentally friendly. That could be a constraint. Your time frame. We've only got 12 hours with this machine down, but I can't possibly throw enough people at this to get this done by hand. Is that a thing with the manpower? And at this point, if you're coming up with your end goal, you're starting to draft some of these limiting factors that you might have. That's a great start. You won't have to have them all, because as you start going through the details of the process of performing this cleaning project, you'll identify more of these limiting factors as you go. Okay, but this will be a really great starting point with your process. the reverse engineering. This is something that I have just, over the years of doing what I've done, I've realized that this is really the list of potential ways to clean something in almost any industrial environment. You can either hand clean it. Now, this includes hand cleaning with solvents, right? So anytime somebody's in there with spraying something down, scrubbing something, hand cleaning. Water cleaning with pressure washing or hydroblasting. Dry ice cleaning, sandblasting, sponge blasting. Those 5 are the majority of any cleaning process in any facility that I've ever stepped foot into in years. Are there rare techniques that are every once in a while done, like something like ultrasonic cleaning? Yes, but technically you're using water and a solvent, even doing that. Laser cleaning is a thing that is starting to kind of show up in different sectors. I've used them. They're not there yet. They're not ready yet. Technically, these 5, that's what you're picking from. And that thinking of it this way is going to help you with your design process of trying to tackle something that you need to clean, because it's going to fall into one of these 5. I can't abrade it. You've narrowed it down to 4. If you can't have that abrasion, it's either you got to do it by hand, you have to use water, you have to dry ice blast it, or use some kind of sponge blasting. Again, remember the hand includes the solvents as well. Those are truly your only 4 options if you can't abrade the equipment. If you need to abrade it or you can abrade it, that opens you up to those options, right? Either sandblasting, sponge blasting, or hand abrading, with grinding and things like that, sanding. Those 2 categories that you've got, it helps narrow your thinking down. And when you're considering what method am I going to use to clean this, how difficult is the adherent, what's the risk to my equipment, what am I going to contaminate, environmentally, what can I dispose of? Can I be creating more waste or not? What safety risks are involved with this method? The downtime. I only have this window. I only have this many people in my facility with manpower to be able to perform this cleaning. And then cost versus opportunity costs. We can do it this way, but the machinery that makes us this much a day is going to be down for 5 days. Maybe it is a better alternative to, instead of using solvents and hand cleaning, to maybe dry ice blast that equipment at a higher cost of what the actual cleaning is, but that opportunity cost that you save in that equipment being running the next day versus 5 days later, that's definitely something to consider with all of this. Right. I had some examples in here to go through, just as kind of put your brain in that and how we think about it with a cleaning project that's new to us or different, and maybe you could too. So for this example, say the adherent that's on the surface is easy. It's not a very difficult clean. You can't abrade the equipment, right? We don't want to be scratching it up. Downtime's not an issue. This machine can be down for however long it needs to be. We can't get it wet. It's water sensitive. And we have tons of people with nothing to do right now. I know that's not the case here. Maybe it is there. I doubt it. But in this scenario where it's easy, you got all the time in the world and you have manpower, this is probably a hand cleaning scenario. It is the least economic impact on getting this equipment or this scope of whatever you've got cleaned. This might actually really be that scenario. You look at this one, that's a little tweaked. The second one, it's still an easy adherent. We still don't want to clean up the equipment. Downtime's not an issue. The equipment's not water sensitive, right? You've got manpower. There's no hazardous materials. Maybe cleaning with water is the right scenario with this one, right? Maybe a pressure washing or hydroblasting or steam cleaning or something like that is the right fit here. You come to this one, the adherent's a little tougher. You still can't abrade the equipment. We can't have it down very long. We need this equipment up and running. The water, it is water sensitive. We can't get this equipment wet. we've got some manpower, and there's some areas that trying to do this by hand or even with us, it's going to be difficult. This might be a perfect dry ice blasting scenario. This has got dry ice blasting or cleaning written all over this one, right? This one, you've got to take paint off of this piece of equipment. We all know that there are painted surfaces in these types of production facilities. You're going to have to abrade it if you're doing 100% removal of paint. You have to. That's really the only way to do it. Downtime is a problem. You can't have dust all over your facility, but you know that you're going to have to abrade this equipment. You've got some manpower, some areas that are tough that you couldn't do with a grinder or sanding. This is probably a sponge blasting scenario, right? Keep dust down, but still abrade, keep things contained. Not as dusty as sandblasting, but you have to abrade it to get painted here and off. So you can see by the examples here, you know, it can get convoluted, but ultimately you're picking from your 5 main ways of doing it and thinking about where are my limits with what our process is. And that's going to help you backwards engineer which method you're using and how you're going to go about it. This one, this is the worst case scenario. It's tough. We can't abrade the equipment. We can't have it down very long. We can't have dust. We don't have any manpower, and there's stuff on here that's hard to reach. This probably sounds a lot like what you deal with commonly, and this might not be a terrible scenario for a combination clean, right? If we've got to do something here, maybe the adherent does need a little bit of pre-treatment with one of your solvents, but then come through with dry ice blasting if it can't do it solo. Maybe this is a perfect example for that. So those exist. I want to make sure that I pointed out here that every scenario that you guys are dealing with is going to be different, right? And just coming at it with this lens is going to be helpful for your project design. Always work backwards from the method and then hows, right? This comes in and brings in the design of a project and the validation and verification that it's working properly. You know, once you pin down how you're going to run at this particular cleaning project, you got to document you just got to document the heck out of it. You know, you have to have notes somewhere. You don't want to be a facility that says we've always done it this way just because in the future. Document why you've made these choices and the route that you're going specifically. Perform it and then adjust. You know, yes, maybe this time, maybe dry ice blasting would have worked better here if we could have used solvent on this piece. Or maybe for this section, we should hand clean this part of it, but blast that part of it. And once you get those tweaks done, document. And then next time you have a PM and a down, go about doing it that way. And then you're going to have a time-tested, perfected method for your equipment or parts of your facility moving forward, okay, that you can pass on to other maintenance engineers and maintenance managers and things at your facilities. Examples here, moving quick through here visually. I know that I'm trying to keep my eye on time here as well. Metals and equipment, right? So this was pharmaceutical cleaning we've done for diamond plate. It's one of those weird things. Diamond plate's common in a lot of pharmaceutical facilities, at least here stateside, as surfaces to walk around equipment. How do you clean that when you don't want to get water all over the place? And you don't want to use a chemical solvent? Dry ice blasting does a really nice job of it. This was general manufacturing. This was rust and corrosion clean. This was actually for Toyota. This was Toyota post-Hurricane Katrina many years ago. They had equipment that was underwater. How do I clean this without putting grit into moving equipment and more water into an already wet scenario? Dry ice blasting did a nice job there. Manufacturing equipment. This is an old paper mill. You know, we don't want to be spraying water in this equipment. Solvents aren't going to be doing this. Cleaning this by hand with the intricacies would be impossible. But CO2 or dry ice blasting did a nice job here too. Historic metals, you know, mineral deposits, things like that. This here, thinking about that, you know, it can clean up metals that have corrosion and mineral deposits on them very well without abrading or damaging the metal surface itself. Food production. This is a chocolate manufacturer that we work for. This every year they have us come out, and this is it's not the worst thing. The technicians, out of all things that they blast off, chocolate dust is not their least favorite, right? It's not that terrible, but cleaning this off for their preventative maintenance. It's food grade dry ice blasting, and it does a very nice job of cleaning the surface, and no water, no chemicals involved, with a process like that. Just another picture of this is a very epoxy-like material that's on this production equipment that they have us clean. Yes, this is food and beverage. It's a storage tank, right? Storage vessel. How do we clean this without pressure washing or hand cleaning all this? Dry ice would do a nice job on something like this, and we do a lot of tank cleanings that way. Here, this one was in an ethanol facility. This was an ethanol facility, and we know with the corn involved, right? High starch, high moisture environment, mold is a thing in ethanol facilities. But here in their pump control room, how do you clean that without getting it wet? And, there's intricacies in this. How do I go about doing that? Dry ice blasting is a ticket for something like that. Go right in, no water. You're not creating more mess, and you can clean electronics with it even. Another example of where even your electronics in your facilities that seem like they might be difficult. More production equipment, for example, there. More electronics. This is a glass manufacturing facility, right? Now we've got all these electrical components we can't get wet, but we need intricately cleaned. Motors, right? No water. We can clean electrical components, motors and hoses, and this nest of, imagine trying to clean this with a solvent or by hand. It'd be a nightmare, right? But dry ice blasting can do a really good job there. Turbines. We clean a lot of gas and steam turbines. It's non-abrasive. It's a good way to clean rotary equipment. Some of you might have combined cycle facilities where you might have rotary equipment. Dry ice blasting is great with natural gas equipment. Stators and generators, delicate equipment, very important for keeping that from being abraded or wet. Dry ice is good there. Here's an abrasive example, steam turbines, right? Getting those cleaned with abrasives. More abrasive example here. Dry ice blasting, right? Convection sections. A lot of chemical, petrochemical refining facilities have convection sections for heat, right? For heat in their production process. The tubes there's ways that they're traditionally cleaned with foam and hydroblasting or even sandblasting. Dry ice does a really nice job of cleaning fin tubes and convection sections, boilers, heat exchangers, things like that, is an alternative to maybe how you've done it. Same with more fin tubes here. IDs and distillation equipment. That's a common thing. How do we clean the ID of this? It could potentially be done with dry ice depending on the size of the internal diameter of that piping. But a lot of IDs get cleaned with dry ice blasting. We talked about the electrical equipment, right? Up here, this is a split combination. This facility, just from years of in their production facility, nobody thinks about cleaning the electrical cabinets. Down here was cleaned with dry ice. Up here has not been cleaned yet. But prime example is, how would you go about cleaning that by hand, right? And this offers an alternative. And then your facilities themselves, I know I'm getting close here. Facilities themselves, you might have to clean a ceiling or a wall or floors or structural steel, and you've got to hold it to the same standard of you can't contaminate the rest of your production facility by cleaning that material as well. So it's another way to utilize that CO2 cleaning in that scenario too. cleaning things like this aluminum, without introducing a chemical or water. Paint preparation. We need to repaint in this area, but you don't want to sandblast in the middle of your pharmaceutical company. That's a problem, right? Dry ice blasting can be used for paint prep, or sponge blasting if you need more oomph, right? This is something that, this is using sponge blasting. This is a very dust sensitive environment. This was in the hull of a Navy ship. They needed all this paint stripped off of here, but could not have a bunch of dust. They needed it all contained. So sponge blasting was performed to do 100% removal of paint, and then there was painting performed. Say your production facility is nasty, oily, greasy. How do you do that? You could do it by hand, but imagine the man hours, right? Do you have that capacity to do that? Dry ice blasting might be even something that you can use for something like that in your facilities. All examples of places we've used dry ice blasting there to help out production facilities. Other surfaces, really quick through here. You might have brick at your facility, right? Dry ice does clean brick well. It might need abrasive blasting as well. This would be a scenario of that. This could be, maybe you've got brick and it's got production soot on it. How do I clean it without water? Dry ice. Maybe you need 100% removal, but it's toxic material. I don't know how many of your facilities might have old lead paint in them. I know that we see it a lot here. Anything pre-1970s has lead paint in the facility. You might have an area that you need to do cleaning of that inside your facility. There are ways to do it with things like sponge blasting. Maybe you've got wood structures, not very common in pharmaceutical and food, but maybe you do. And if you do, dry ice blasting does well. This is in the whiskey and bourbon industry. We clean a lot of storage barrels for Kentucky bourbon, right? Kentucky bourbon is stored in what these call rick houses, and we do a lot of cleaning of those for structural inspections. Point being here that surfaces examples for you in your facilities that you may have to deal with. Concrete, here's a good one. This one's good for paint preparation, right? We just need loose and flaky off because we're going to repaint this ceiling over this production line. Dry ice could be good for that. Okay. Very long-winded and very fast, rapid, but I was trying to make sure I was respectful of the time frame there, and I think I did okay in staying in my limits.
Okay, thanks, Devin. If anyone wants to put any questions in the chat, we'll quickly go through them. They'll realise that we're sort of after time as it is. Just looking at things that are in there already. Devin, is question: Are there supply chain challenges around getting the dry ice from the manufacturer to the point of use before it sort of has sublimed?
Okay, yeah, that's a really good question. Typically, and there are different qualities of dry ice, but well-made dry ice is best within three to 4 business days of production. And so if you've got something that you're thinking about cleaning at your facility on a regular, you would not want to have dry ice shipped from a long distance that takes days to get there, because that's going to decrease quality. And you wouldn't want to have a large amount sitting in your facility just sublimating for days. So you would want to be thinking about how much I'm going to need and make sure it's from the closest source and get it there kind of when you need it type of scenario.
Do you source it from local suppliers, or do you sort of ship it around from your preferred source?
Usually local suppliers is the best route to go, just because of that sublimation problem, especially since the distance that we travel to work, the magnitude of the United States, sometimes it might be a 24-hour drive from our shop to where we're going. So it has to be something local. That's the best route to go about doing that. Unless it's in an area where there's no local supplier that has the quality of ice that we prefer, then we might bring it with us if it's able to be done that way.
Yeah. Then there's another question in terms of localizing the displaced waste so that it doesn't you end up throughout the workshop or factory or what have you. You touched on sort of the actual disposal itself in terms of collecting the displaced stuff so it's in one place so it can be disposed of. Is there like, can you use like a suction hose or something like that to sort of keep it together?
Yeah, you can. Different ways for collection of it. It could be as simple as a canister vac. In the pharmaceuticals realm, in the food and beverage realm, there are vacuums that are often used for combustible dust, but they're HEPA filtered backpack vacs. And those are really good if you're dealing with an adherent that is potentially hazardous. You can use that to suck up material when you're finished, or as simple as a canister vac if it's not as big of a deal. Or in some scenarios that are larger scale, maybe really dusty, a diesel dust collector is something that you might use that pulls a large negative draw, and material can be swept into that, and it's collected externally in a diesel dust collector. Sometimes I think it's also common in food facilities, pharma and food, if they have a cyclone dust collection system that they use already around that particular line, it's the material can be contained, collected, and then pushed into that collection system itself, because it'll go right into your own dust collection cyclone at your facility with that same material that it's already used to disposing of. And that's a common way in those production facilities as well.
Okay. Okay, last call for questions. If anybody wants to follow up with you, was your email on the first slide?
I think I had it. Yes, on the last slide, I've got it there.
Yeah.
And I'm on LinkedIn as well. If you want to connect on that, I'd be happy to answer any questions you've got. I'd just like to be helpful if I can.
Yeah.